All right, we learned MPLS, multi-protocol label switching. Now, the reason why we need this is we want to avoid route lookup, one thing. Secondly, we want to avoid looking into the network layer of each packet. Two things I have said. First thing, we want to avoid route lookup. Secondly, we want to avoid looking into layer 3 header. All right. So let me tell you one thing. Even before you enable MPLS, we are not doing route lookup. We are not looking into the routing table. Even before MPLS, we are not really looking into the routing table. We are looking into Ceph table. We are looking into Ceph table. So Cisco Express Forwarding, which is also called as forwarding information base. This is the table that has got routing information. And where is this located? It is located in layer 2. So this table is in layer 2, whereas the routing table is in layer 3 of the router. Router has got two levels in engine, two level of engines, layer 2 engine and layer 3 engine. For layer 2, there is a set of chipset on the motherboard. That's layer 2 engine. For layer 3, there is another set of chipset on the motherboard. That's layer 3 engine. So even before you enable MPLS, you have this layer 2 engine which download the routing table in layer 2 level, so that when a packet comes to the router need not to send the packet to layer 3 engine. It can refer the layer 2 engine and decide the exit interface. So that type of route lookup is what we have on every vendor, not only on Cisco. In Cisco, we call that a Ceph. The others call it as FIB, forwarding information based table. Fine. Now, when you enable MPLS, what happens? We alter this Ceph or FIB table. How? We add labels for every destination, for each and every destination that is there in the Ceph table. That is there in the FIB table. So you are going to add, when you enable MPLS, you are going to add labels. You're going to add labels. By adding labels, you can quicken the routing decision. Meaning, instead of reading that big routing table, you just now need to look into this label forwarding information base. Spelling wrong. EL. LE now. Right? Label. Able, label. So using the LFIB table, to see the table, the command that we use is show MPLS forwarding table. And if you want to see the Ceph table, show IP Ceph. Now you will see in this incoming label as well as outgoing label. Whereas in the Ceph table, you will have only outgoing label. So on the router side, this is the alteration that happens when you enable MPLS. Labels get generated and assigned for every single network. Not only that, on the outgoing field, the labels given by the neighbor will be filled. Local label on the in local label, the label generated by this router. In the outgoing label, the label given by the neighbors. Right? That if you want to see, you need to type show MPLS forwarding table. If you want to see only the outgoing label for every destination, then you type show IPsef. So not only this is happening, even when the packet comes inside a router, it will go only up to MPLS layer, MPLS header, where it finds the label to know the destination. So there is no need to do layer 3 header lookup. We have seen all these things in our previous class. I also said when you enable MPLS, LDP gets enabled. Label distribution protocol. Can anyone say the port number of LDP? I told you on the previous class. If you Google, everyone can say. What Bala? Very fast you are typing it. No need to tell like that. You should tell from your mind, from your memory. TCP 646. LDP port number is TCP 646. Yeah. Now, can anyone say the other protocol equivalent to LDP? There is another Cisco proprietary protocol which is same like TDP, Tag Distribution Protocol. This DP stands for distribution, L stands for label, T stands for tag distribution protocol. This is for LDP. TDP port number is UDP 711. Okay. It uses both UDP initially, later it will, after discovering neighbor, it will switch to TCP. Now, I'm going to do a lab for you and make it more clear of what you have seen so far. Coding, I'll take a notepad to make this configuration quicker. Except MPLS, all the rest of the configurations I will do in the notepad. This I'm doing for router 1. Alright, so meanwhile, configuration is over. I just pasted the router 1's configuration. If you notice here, I said hostname, I have given loopback interface and address, and Ethernet 00 another address, and then I have enabled OSPF. Very handy. Let me also finish router 2 and the other routers. I got one more interface. 23. All right, let me do router 3 now. $34. That's all. This will go on router 3. Let us do router 4. Router 4's Ethernet 00. Router 4. One last router, then we will begin MPLS. Ethernet 00 will be 45.5. Okay. That's all. We are going to wait for OSPF to come up and then we will ping between R5 to R1. After that, we will start our MPLS configuration. Okay, that's the plan. Has the OSPF come or not? Why both of you are silent today? No, dear, it is already there. You see the last line there. So let us ping and see. Ping 1.1.1.1 with the source, file. See, I'm able to ping, which means OSPF is good. If you wish to do trace route, good, you should do it. Because after MPLS, when I trace route, you will see something unique, some differences in tracing the route. Right now, we are not having MPLS. Before MPLS, see how the trace looks like. You see, it goes to router 4, router 3, and 2. That's all, 4 hops. That is all. Now, after MPLS, you will see even the labels on each hops. Focus. You will see what? Labels. All right. Now, for your better understanding, I'm going to allocate some range of labels for each router. See, this is only for your understanding. You don't need to do in this production, this one in the production. What I'm going to do, I'm going to tell router 1, you should use only labels from, let's say, 100 to 199. In router 2, I'm going to say you should use 200 to 299, 300 to 399, 400 to 499. Listen, what is the biggest label? What is the maximum size? What is the range of labels? You know anything like that? Do you have any answer for this? Range of labels. What's the maximum label you can have? In the previous class, I told you in MPLS header we have 32 bits, in which 20 bit is label, isn't it? Didn't I say this? Yeah. And 3 bit is experimental. 1 bit is bottom of a stack, and then say 8 bit is TTL. So if you have 20 bit, then it is 2 to the power of 20. What is the number? It's a very big number actually. 2 to the power of 20. It is 1,048,576. These many labels you have, in which up to label number 15, labels. Labels. Is it clear? Labels. Do you hear me? Right? You have 20 bit. Label from 1 to 15 is reserved. So label from 16 to this bit. Okay. Now, in that, what I'm saying is only this much I'm using, 100 to 199. For the networks of router 1, it should not use label 500. It should use only within this range. If you don't say this, it will randomly pick it. It will start from 16 onwards. It will start allocating. See, it's not necessary to set some range of labels. If two router uses the same label, it is okay, nothing wrong. But for your learning purpose, I'm doing this. When you do like this and learn MPLS, you'll have more clarity on MPLS labels. Okay, so shall I enable MPLS now? Did you understand what we are planning to do? Silence. Very silent. Right. On router 5, I'm going to give label number 500 to 599. Okay, so first thing is enable MPLS. Enabling MPLS is very simple. Only one command, MPLS IP. That's all. You have to type MPLS IP. You need to enable this command. You need to put this command under the interface. Globally also you can put if you want, but it is not mandatory. When you put on interface, it automatically enables the MPLS engine. The enables the MPLS, not engine, feature globally. But only on that interface where you put this command, the MPLS will work. So you may have 10 interface. When you put globally, don't expect all 10 interface to run MPLS. No, it won't run. You also need to go and enable under the interface. Listen carefully. I'm going to router 1. and I'm saying in the global mode, MPLS IP. Do you think MPLS is running on all the interface? No. You see, show MPLS interfaces. No interface is running. Then why am I doing this? This is to enable the feature. But if you will go to any interface and say MPLS IP, then even if you don't have this command, the MPLS will start working. What I'm trying to say is giving on the global configuration mode is not mandate. Just go to the interface wherever you want MPLS and enable it. You cannot enable MPLS on the loopback interface. See what happens when I enable. What did I say? Can anyone repeat? Yes. Why? Because it's a virtual interface. You don't need a label distribution on the virtual interface. It's not a physical one. Only on a physical wire you can distribute. Now on the loopback, when you say MPLS IP, see, MPLS is not supported on interface loopback. You understand? Okay. Next. There is one condition. Listen to me very carefully. This is not a routing protocol. So, the router IDs of the routers need to be a pingable address. Listen carefully. In OSPF, if the router IDs of OSPF is not pinging, it is okay. Because there it is only a ID. That's a routing protocol. But this is MPLS. What this MPLS will do, it will pick the loopback interface as the router ID. For example, if router 1 picks this address, of course it is going to pick only this address, the loopback address as the router ID. Now router 1 will go and talk to this guy. Hey, you know my buddy, I'm 1.1.1.1 talking to you. Router 2 will check whether I know this guy. Router 2 will check whether I have root in the routing table. If we don't have root, then it cannot form neighbor, MPLS, LDP neighbor. It cannot form neighbor if that loopback router ID is not pingable. It needs to be a pingable address. The router ID need to be a pingable address. Did you understand what I'm saying? You see, and router 2, router ID is going to be 2.2.2.2. If this is not pinging, it won't form neighbor. You want to see? I'm going to do the testing, you see. That's why we enabled OSPF. If I forget to enable OSPF on loopback, see, I'm going to remove OSPF on loopback. Interface loopback 0, no IP OSPF. On which router I am removing? I know IP OSPF 1 area 100. I have removed. Now, from R1, can I ping this? Give some time, the route will be removed. See, it's not pinging now. Okay? It is not pinging. See what happens if I enable MPLS. I'm going to R2. Interface loopback 0. Sorry, not loopback. Interface Ethernet 0/0. MPLS IP. Okay? Now, I'm checking whether I can see neighbor. Show IP. Sorry, show MPLS, LDP, neighbor. See, there is no neighbor. Neighbor won't come. Show MPLS, LDP, neighbor. The neighbor will never come. Why? Because router 2 is saying, I'm 2.2.2.2. Router 1 says, I don't know you. I don't know you. Router 2 says, hey, I'm your neighbor, man. Router 1 says, wait, let me check the routing table. Show IP route. 2.2.2.2. No, man, I don't know you. I don't know you. Okay. Then router 2 gets angry. What do you mean? Let me check. Loopback 0. IP. OSPF 1. Area 100. Now it says, hey, you check your routing table now. Yeah, I got the route. Okay. Look at this. This is what MPLS troubleshooting. Actually, they make a mistake and they say do troubleshooting. Now, why you made mistake in first place? Because you don't know the fundamentals. That's why you make mistake. That's why trouble comes. And you want someone to shoot it. That's very bad. So when you learn, you need to learn proper. You see, like OSPF, MPLS picks the loopback interface address as the router ID and talks to the neighbor. If the neighbor do not know that router ID in the routing table, if it cannot ping the router ID of the neighbor, it cannot form neighbors. LDP neighbor cannot form. Now you see, earlier when I was typing this command, nothing was coming, but now it says, I have a neighbor. Yeah, and you see the port number 646. I say no, LDP uses TCP 646. You see, TCP connection. Okay, I have a question for you. In which router I am seeing this? R1. Between which two routers you have neighbor? Between 22222 and 11111. Now question is this. Who initiated this MPLS LDP neighbor session? From this output you should tell me who leads the session. Is it router 1 or exactly? How you know, sir? Where is source? Okay, you are very clever, man. But okay, that is a very nice clue. This is another clue. You see, for router 2, the port number is a random port number. Usually the initiator, he will use his source port number random and the destination port number based on what service you are looking for. You're looking for LDP. So whoever has got the source port number random, they are the initiators. See, same like OSPF, between these two routers, they compare the router ID. And the one with the bigger router ID will become the designated router. You got it? The one with the bigger router ID. Now, if I enable MPLS on router 3, between router 2 and router 3, who will be the DR? Who will be the designated router? Who will lead the session? Who will initiate the session? Bala, Unara, Yamanti. Yes, 3333 will initiate. Okay, let us go enable in router 2 Ethernet 01 MPLS IP. Simple, one command only. And then I'll go to router 3 interface range command Ethernet 0/0-1. I'm enabling MPLS on both the interface at the same time. And now you see the neighbor has come. Check now. Show MPLS LDP neighbor. Who initiated? Router 3 initiated. Random port number. So the source is not the clue. Who is the initiator? The one with the random port number. This is counter. Okay. The one thing I forgot. What? I said I want to give this range port number. Because you didn't set range, you see now, show MPLS LDP, show MPLS forwarding table. You see the labels are starting from 16, 17, 18. But I want to give this range. So let me go and tell router 3. In the global mode, you need to say MPLS label range. What's the range for router 3? 300 to 399. MPLS range 300 to 399. Okay, no hyphen. All right, now because you changed the range, you have to refresh the MPLS. No MPLS IP. Just remove this globally and put back MPLS IP. Likewise, let me also do it on router 2. Tell me what is the command to set the range? MPLS label range 200 to 299. Next, router 1. MPLS label range 100 to 199. Now let's, okay, no MPLS IP, MPLS IP. I'm just refreshing. Likewise here, no MPLS IP, MPLS. All right. Now let us check the labels. Show MPLS forwarding. Look at this. Whatever the label coming from router 3, it will start with 300. Router 3 has distributed these labels to router 2. And whatever the label that is locally generated, they all start with 200 because it is a router 2. Go and check on router 3. Show MPLS forwarding thing. You see? The label given by router 2 to reach 1111 is 200. The local labels are 300. Okay, now let us go to router 4. Interface range Ethernet 0/0-1 MPLS. Oh, I think we have done this already. I need to say range command. MPLS label range 400 to 499. Next, router 5. Correct. Correct. That's the meaning. It should not use any other label. It should use only within this range. Yes. Okay, here MPLS is not enabled. In interface range Ethernet 0/0-1 MPLS IP. Okay. Now you see show MPLS forwarding. Look at this. All start with 400 local label. And router 3 has given saying use 300 if you want to go to 111. Use 301 if you want to go to 222. Router 3 has given to router 4. We'll talk about this later. Now go to router 5. Interface Ethernet 0/0 MPLS IP, and then globally you type MPLS label range 500 to 599. Okay. Now here let me show MPLS for. See, I gave range bit late, so it is already given label. Let us refresh it. No MPLS IP, then MPLS. Now if you go back and check, you see the local labels are 500. Okay, it's now ready for tracing the route. You remember earlier when I was tracing the route, we were not having any labels. Earlier when I was tracing the route, where is that? Yeah, this is the trace we did earlier. Do you see any labels here? No. But now you see when I trace route. You will see label 400 because I see for 11111 the outgoing label is 400. It is going to come now. Wait, look at this. I said no. and it goes to router 3 with the label given by router 3, which is 300, and then 200, the label given by router 2. Look at this. And then it will not have any label when it goes to router 1. No labels, which is called PHP, penultimate hop. See, no labels. Penultimate hop popping. What it will do, before sending to the ultimate router, see, I'm tracing the route 11111. Where is 11111 on router 1? So before sending to router 1, it will pop the label. Why? Because to deliver the packet to the loopback interface, it has to go through the routing process. So it throws the label and sends to router 1, so that in router 1, it need not do MPLS lookup. It can straight away do the route lookup. To deliver the packet, it needs to do the route lookup. If it don't pop the label, then it has to do two lookups. Label lookup and then yeah, correct. Yes, you're right. So this is a simple lab on MPLS. More in depth of this we'll see in the next